example 2, we're going to write the equation of this function. Okay, so I've given you the graph. Let's try to create the equation. Okay, give me some thoughts. It's going to be in this form. I'll give you a hint. It's going to be in this form. Y equals c to the x. And our goal is going to be to find out that value c. C is going to be 5. Okay, so let's go with Joe's suggestion here. C is 5. Let's see if that makes sense in terms of our points. Okay, so if C was 5, this first point, 1, 5, would mean I put in 1 for x, and I should get 5 for y. So let's see if that happens. Okay, put in 1 for x, that'll be 5 to the 1, equals, that'll equal y. What does that equal, 5 to the 1? 5, okay, good. So that point works, 1, 5 works in that equation. What about 2, 25? Let's see if that works. That means I would put 2 for x, and I should get 25 for y. Does that happen? Mm-hmm. Yeah, it should be pretty obvious, right? So that one also works. 225 also checks. So, good. This is our equation here. Y equals 5 to the x. Super hard. Okay, next page. Let's take a look at this one. Here's another graph that we're going to find the equation of. We've got the points negative 2, 16 and negative 1, 4. And again, it's going to be in this form. Y equals c to the x. And we want to figure out what is that value c, such that these points work. Sorry?
C is going to be negative.
Maybe?
Negative 4.
Negative 4? Okay, let's try that. So Tobias is suggesting y equals negative 4 to the x. Put that in brackets. Let's see if that works. So let's test the points negative 1, 4 and see if both sides equal the same thing. So negative 4 to the power of negative 1 would be negative 1 over 4, which is not what I wanted. I wanted 4. Drat. Okay, that's not going to work. Other ideas?
Wouldn't it be negative x? Negative x?
Negative x? Y equals negative x?
Oh, y equals 4 and then negative x.
4 to the negative x. I see what you're saying. Can I change just a little bit what you're thinking?
Sure.
Yeah.
4 to the negative x. Instead of doing that, I'm going to write it as 1 over 4 all to the x, which is essentially the same thing. I'll show you why. Okay, this is like going 4 to the negative 1 times x, right? And this part here turns into 1 over 4. Does that make sense? So I'm just going to keep that variable positive. And I'm going to have a fraction as my base. So let's see if that works. Okay, so we're going to test the point 1, 4 again. See if that works. So y equals 1 over 4 to the power of 1. Does that come out as, uh-oh, what happened here? It doesn't come out. Phooey!
What do you mean?
Oh, sorry, it's negative 1, 4. That's why. The point is negative 1, 4. Yeah, right there, negative 1, 4. So this should be like that. There we go. Now it works. So this negative exponent flips this fraction over, and we get 4. So they check out. You guys follow what I'm doing? We're taking our potential equation and we're testing to see if those points actually work. Let's test the other one. That other one was negative 2, 16. So let's test that, negative 2 and 16. So y equals 1 over 4 to the power of negative 2. You guys remember how these work?
So yeah, it's going to flip the fraction and square it, right?
It's going to flip the fraction and square it. Good. Yeah. So this will be 4 to the power of 2, which is 16. Okay, which checks out nicely. So good. We got the equation. Y equals a quarter to the power of x. Or Nathan, you suggested something else that would work, but it's usually helpful to try to keep your exponents positive.